Thank you for the time. This time, I will present my research in 6th Borobudur International Symposium on Science and Technology 2024. My research entitled Detection of Surface Damage on Components of Heavy Equipment Machine using Convolutional Neural Network. I am Hidayat. I am from Polytechnic Negeri Samarinda, Indonesia. First of all, I will describe briefly about my research background. According to the theory of applied failure analysis, there are four types of damage in the engine components commonly occur. This study, my research focused on the two components. The components is crankshaft and camshaft. And commonly damage on the surface component, there are many types, but in this time I will describe four types commonly occur in surface components. The first is abrasive wear, second is adhesive wear, and the third corrosion or cavitation corrosion, and then the fourth is contact stress fatigue. The methods for identify the surface failures in the components by technician, usually using manually by visual inspection and damage classification. First, the technician doing visual observation of damaged component, and then after that the technician classify the damage using a literature or manual book. Based on the research background, in this research, we define the purpose of research is to develop a system that will help technicians or mechanics in identify components damage types automatically. And this system in this study was developed from one aspect of machine learning, especially we using the algorithm convolutional neural network. The next is research methods. In this study, we obtain the data in the form of image from PT Trakindo Utama, and then the data that we obtain, the total data we obtain is about 5,077 data, and then the 5,000 data is component made by iron, and then in which about 3,700 data is image of crankshaft and camshaft components. The next is the data processing. In this investigation, the object will be recognized in 10 different classifications. In this time, we make 10 data class. And then the first is abrasive wear, adhesive wear, corrosion, contact stress fatigue, cavitation erosion, fretting corrosion, erosion, and then brittle fracture, ductile fracture, and then oil passage. Then the data set of the crankshaft and camshaft image used for training, we choose just 951 images. Actually, in this time, we select the high quality of image. Then the data of camshaft and the crankshaft is 951. And then the data set image is manually marked with a bounding box like this, and then the data set is divided into two categories. The first, we training about 796 photo, and then we make evaluation about 187 images. This is the preparing transfer learning, and then in this slide we can see we using TensorFlow object for detection API and SSD mobile net v2 in the machine learning model. Then as for the SSD, we using SSD function to perform the detection, and then mobile net v2 serve to perform classification. And here we can see to shorten the training time, the mobile net v2 SSD checkpoint file that has been trained in the open image v4 dataset. Then about the dataset, we using 601 classes to classify the data to transfer learning. Now the next slide is the results. So here we can see some of the data results from the training process using convolutional neural networks algorithm are displayed on this slide. And then the data is restricted in its value over the 30% confidence value. And then some of data generate contains damage reading that are still undecidable regarding the nature of damage. Then consequently, and this data is necessary to select the data in high quality. In the next slides, here we can see the system that can also detect the several different types of damage in a single image. And here we can see the system can detect adhesive wear and corrosion, and then also in this image adhesive wear and abrasive wear. And then the third image is the algorithm can detect ductile fracture and also adhesive wear. And lastly, the conclusion of this presentation is the use of machine learning, is more specifically convolutional neural network, to detect damage crankshaft and crankshaft component has been carried out. And then the confidence score for training after 5,000 steps are still mostly in range of 30 and 50% and not above 90%. The accuracy of the analysis result for the types damage, corrosion, erosion, cavitation, erosion is still very lacking, which is caused by lack of image data. So it is still necessary to increase the number of data sets for training data. And then the fourth, the presence of such image artifacts and low confidence value, so that it still needs supervising from human being. Thank you for the time. If you have a question, you can write down in Q&A in this conference. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.